I have in a couple of these examples.
Ah, okay.
I don't think keep cases is absolutely devastatingly bad.
It's one of the name options we have. There's a subsection there with a couple of other ones we looked at. Yeah, we don't like prune. Yeah, sift was another one I kind of thought of. It might be a little esoteric, and filter would work, but we have lots of filters. And,
oh no.
Yeah.
Let me see. Sieve. That's a bit obscure.
Absolutely not sieve. Number theory connotations.
I said sift, but yes.
Yeah. Sift is I'm okay with.
Yeah. My only concern with keep cases is that as soon as we call it cases, we start thinking about patterns. Which
doesn't delete cases support the list structure too? I mean, okay, if I simply say here, cases.
I mean, cases takes a pattern, right? So you'd have to do alternatives at. Yeah. Yep. So in this case,
it's the same result.
The same result. It would not be if you want to preserve the positional cases that didn't match, which was where the idea originally came from. Was, this is in some ways a filtering way to preserve the structure of the data, whereas cases is inherently going to give you back a list, a flat list.
Right. The problem with prune is it's the wrong way around.
Right.
Okay, what is this doing? What is the...
Well, why not keep elements? Because you have delete elements. That also takes a list of, but it doesn't accept a level. So
delete. That's a fairly added thing.
Maybe it makes sense to extend delete elements with the level, and also keep elements kind of would work the same way. So they would be.
Well, this is removes all elements, but one could give it a thing to put in their place, I suppose. I don't know why one would do that, because one could just use replace for that.
But is the first argument being a list more restrictive than the first argument being a general expression there?
Maybe so. But look, I agree keep elements is reasonable in the sense that it
matches syntactically what we were talking about.
Well, it doesn't seem bad, actually. I mean, this funky syntax with n instances, one could even support here. Keep only up to that number of instances of each of these things. See what I'm saying?
Yeah. Yeah, I can't think of an immediate use case for it, but we could certainly support it.
I can imagine ones, but I think this is a reasonable name. Now, in terms of the level spec, what does it do at the multi-level case?
I mean, the multi-level case is tricky because, if you take the toy implementation I have here and you put in level 2, it's just going to flatten it down to just 2 elements in this particular input, or I guess 3 elements.
Sorry, I'm sorry. If you do what here?
So the first line I have there is a toy implementation of prune. And if you change it from in that matrix form example, if you remove the braces around the 2, it'll be a multi-level spec and it'll just flatten the whole thing down to 3 missings.
I'm totally confused. It's because it looks at, because it's like map. It looks at the higher levels.
Right. It looks at the higher levels first and says, these aren't in the list of expected.
Well, it's a question of what the level
elements.
spec is supposed to be.
Right. So if you were going to do this with a level spec,
Is there a point in doing it with a level spec, or can you just map this thing over the thing and get the same results?
I mean, you should be able to map it. Yeah, you could map at minimally, but yeah.
Well, I mean, why do you have to map at?
Or-
Why isn't there just a map? Whatever you can do with level spec here, you can do with a map.
Yeah, that's true. Okay.
I don't think we should have a level spec. I think it's confusing, as you say, because it could smoosh it could blow the thing up at a higher level. And then this looks good. Let's do it.
Yeah. One spin-off question then is delete elements currently is set up for lists, I believe. I don't believe it works on arbitrary expressions. We could potentially extend it to, or if we wanted to do that with keep elements, or we could just say keep elements and delete elements only work on lists. Oh, actually delete elements does work on arbitrary expressions. It just wasn't, yeah.
I kind of thought it did.
Yeah, I mean, the list case is certainly the simplest
The object can have any head, not necessarily list.
Yep. Okay.
Okay.
Easy enough then.
Right, let's go on. Merge and keys.
So this was a suggestion that Brad had, and I can have him talk about it a little more, but looking to get some more information about about the keys during messaging and whether this is something that could be generalized.
Yeah, and I was thinking about it a little more today. If the keys themselves contain some important information, then when you're doing the merge, you could also be switching on keys exactly how you do the merge.
Yes, but what does merge normally take?
It's just the values.
Using the function to combine values. Well, why isn't this a supplied play?
Yeah, that would be kind of a natural place to have it there.
Because I mean, there are all kinds of weird things, like the position and the
The
association.
index, yeah.
Right, there are all kinds of things you might want.
I think the positions in the association, it would be a little bit lower down the priority list.
Yeah, I understand, but what are we going to do? We can't change merge to have that function take more than one argument. So what are we going to do? We have to have a thing which basically specifies some kind of handler keys or something.
Mm-hmm. Yeah, I guess I hadn't thought about the intersection of supplied and messaging, but it would be a nice way to effectively have that meta information available.
Yep.
Okay. Yeah, I will pass that along to Itai for the next discussion on supply, just as a use case.
Fine. The fact that we keep on calling this thing supplied, even though it's had many other names, is a sign.
Yeah, I think it's pretty intuitive what it means when we call it supplied.
Right. What were the other names we had for it, which we don't remember anymore?
We had including. There's some variation of includes.
Okay.
Well, maybe some others, but we should get back to talking about.
Sorry for my ignorance here, but how is supplied a workaround for this thing about missing keys?
Because supplied is a way of specifying, look, the idea is that you say map supplied F, comma, and then this can tell you, the index, the value, and this is then supplying to F both index and value. Whereas normally without the supplied, F just gets the value. Get what I'm saying?
And I guess key could be in there too. Index
Exactly.
key.
Yeah, exactly. So I mean, for example, or keys plural or whatever, we can have named. The whole point is that in a given situation, like map, for example, that you can put a supplied there, which has a certain known collection of possible values that it can fishes out of the map environment. Get what I'm saying? So here in this case, with merge, we would say this blah, 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 comma, supplied, and then the comparator. Get what I'm saying? So you could just say supplied of this, right?
Okay. I think what I'm getting here is that it puts more power into the user's hands about having extra arguments and then how to order them.
Yeah. Yeah.
Yeah, it
And
effectively lets
associate-
you add like meta information to the evaluation.
From the environment. It's
Yeah.
information from the environment. In this case, information from the merge. In the case of map, information from the map.
Mhm.
Like, you know, what was the depth, for example, of this, at which this F, you know, is occurring. Let's say this map had been a map all. Right? It would have different depth information, et cetera, et cetera, et cetera. It's like supplying environmental meta information into the function application.
And as to your question, Stephen, I think supplied is next up on the list for LCC. There've just been some scheduling conflicts that have kept us
Okay.
from getting all the important parties together.
Okay.
So we had started talking about this last time also, the idea of modernizing REAP or having a variant of REAP that allows us to create an association. The main sticking points being, you know, basically we'd have a result key, and then we would have the different elements that have been sewn with their associated tags. You know, the single
Yes.
argument form of REAP will grab all of the sewn keys, but you don't necessarily know what order they're going to be in. But the sticking point we ran into is what would we call the unlabeled or the untagged sewn elements?
That
Anything
is
can
good.
be a tag.
That is actually documented as none.
I understand that, but the problem is if they're in an association and they're all called none, they will crush. They'll merge. I'm saying, well, actually, no, I see. What you're saying is, this is the list of all things sewn with the tag none, correct?
Yeah, so the single argument version of so is equivalent to so of whatever with none. I had forgotten about that last time we were looking at this.
Okay, fine. Well, then that's an answer.
Mhm. So then the question is, you know, I don't know that there's a way to really integrate this into REAP itself.
Well,
We
let's
have
look
a
at
very-
REAP. Let's look at REAP. Let's see whether REAP has a property option. Okay, let's look at these other cases. REAP's only ones that match this. Okay, so that's like a key cases.
Mhm.
What's this?
So I believe that one basically applies F to the tag and elements. I haven't really
Right.
used that.
So
other
if you
than
made
this.
F rule,
Mhm.
it would almost be the same as this, except it'd be a list of rules instead of an association.
I think this could fit with a fourth argument being association. And then it would be a pair FG, like we use in distribution and things like that.
Hmm.
Sorry, distribute.
Right. It's a kind of
Well, if you
map and
had
reduce.
association as a fourth argument, is there anything that would actually work for F?
Or would it have to be rule?
Right. It's almost like you want a magic string as the third argument. that does this.
Yeah, otherwise I think it would have to be pure function of slot 2, right?
Yeah, something like that.
Well, that's an argument for reap association. Is that the right way around? Is that what would be association reap? No, it's reap association. It
Mhm.
returns an association, right?
Yeah.
Or it returns a list that the second argument is association. Depends if you want this result zone level or not.
Well, maybe reap association. I mean, it probably needs that pattern argument too. It doesn't need the F argument, but it does need the pattern argument. Correct?
Yeah.
Yes.
But for the F, it could have a property argument.
On the resource function, I did support that F argument, although it was a long time ago. I don't remember exactly the behavior.
Well, okay, so one possibility is there's a single association that has both the tag, the so-and tags, and the result in it, because I think this two-level association is pretty ugly.
Mhm.
The question is, what's the name of the magic? I mean, because the tags can be anything, right?
Yeah.
And,
they can
and
be
you do
arbitrary
need the
expressions.
output of the entire evaluation.
Sure.
So you do need something wrapping the association.
Okay, so the question is, I mean, we do not want to have something where you have a list of the outer level and then it's an association. That seems really ugly. I mean, the third argument of reap association could be a property thing that picks what form you want this output in.
Why why does reap association doesn't return row delayed for the tagged one? For the result, it's a delayed row, but not for the tag.
This one here, or those ones there.
But the none one. Maybe I like so unvalidated result, something that I want to be unvalidated. There's
Yeah, I
no
agree.
to do it.
Yes, I agree. That's a reasonable point. But okay, so the way you use this is, yeah, you'd say, you know, R equals reap association of blah, 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 thing sub result, thing sub so on. I think it's okay. This looks fairly reasonable to me. I
Yeah.
wouldn't put in a, go ahead.
I like having the top level association like that because your evaluation might return something like nothing or a sequence or something like that, which would be hard to figure out with a list.
Yes. Okay. All right. So I think we got another winner there.
Okay.
Association key deflatten. That doesn't sound promising in terms of a
Right.
name.
The name's
Yes,
not
it's-
great. It's maybe descriptive, but it's a little wordy. But
There's an
basically-
Is the word
association
association needed?
Well, hold on. Let's just see what it does first.
I made it as an inverse for another resource function called association key flatten. Or maybe I made the other one. I don't remember which one I made.
What does it do?
So it takes like it basically just creates nested associations from a flat association where your keys are just a list of the positions.
Yeah. So each element in the list in the key is another level of association that's been basically squashed in this case.
Yeah, I understand.
This is a reconstruct association from
It's kind of a transpose operation, except that it.
Right.
Yeah.
What's that?
yeah, it's very much like a transpose association.
So we have an association transpose, don't we?
Yes.
What does it do?
I don't think we do.
Oh no, don't we? Okay.
I think
maybe
if
there's
it's,
first.
I think if it's square, transpose might work on an association,
And general utilities, we have one.
or rectangular. I mean,
What do we have in general utilities?
Association transpose.
Well, maybe this is that. I mean, this should be a version of that where there's a level spec.
That is more for like if you have a list of associations, it will give you an association where each item is a list and vice versa. So it's kind of a different thing.
And what is this doing then? I mean, this is just exchanging list keys.
Yeah, this is more of, I guess you could call it like a key transpose.
This is kind of, I mean, it's interesting. I just don't quite understand. I mean, it reminds me of, join across, which some people think is the most magnificent thing in the world, and most people don't understand what it does.
Yeah. So I guess a use case that I thought was interesting with this is we already have file system map, which works on basically a tree-like structure for a file association and creates these sort of nested levels of associations.
Yep.
And oftentimes you get things like file names that will be, if you break a file name up into its elements, you'll get lots of matching lists that will be like this, where each element numerically in order will correspond to a level of basically a flattened association. So if you file name split a bunch of files, you'll get a file structure, or you'll get an association structure that looks a lot like this. And being able to merge it back into a single large or deeply nested association can be useful.
I agree.
If that's strong enough of a use case to have a system function, I don't entirely know. But I've seen data like this occasionally and wanted to basically squash it into a single association.
Here's the deal. There are a zillion array and association, array like list arrays, association arrays. There are a zillion of these operations, which we kind of need this general formalism to talk about. Whether this is, from string diagrams to this to that, there's just a lot of array gymnastics. And I feel like we don't have a good principled way of talking about them at this time. We've had in the past a certain number of things like flatten and transpose and things of this kind. Okay.
We have the option allowed heads, and that is able to tell some of these functions you are talking about that associations are allowed.
Yeah, that's pretty obscure. I mean, what I'm asking is, you're trying to rearrange. I don't have a good sense, and perhaps it would help if there were graphical representations of this, of what, this various array gymnastics, what they mean, and how would I ask for something like this? You get what I'm saying? I mean, like in the modern world of LLM-based programming, you might just give an example of what you want, and it might deduce this is the gymnastics you're trying to do. I mean, in other words, there's got to be a way to do this, that either you say, I understand I have a way to represent this complicated nested, list association combo thing in a way that's some kind of diagrammatic thing, and I can say I want to turn this into that, or some kind of symbolic, almost type level representation of these things. I want to turn this into that. Or I literally just say, I've got an example of this. I'm gonna, I want it to turn into that by example. Do you get what I'm saying?
Yeah, like
Yes.
sort of coercing something into another pattern, essentially, right?
Yes. Yes. Yeah, I mean, and right, but the question is how to specify that. Do you get what I'm saying?
Yeah, I know what you mean. It sounds difficult.
Well, right, but I mean, I don't know. Yeah, I mean that's what I'm trying to understand.
Like if you have a flat list of integers, for example, and you specify a pattern that's like a list of lists with, you know, triple underscore or whatever. So you're just defining a pattern where it's a list of lists. Could we somehow infer that that should be partition or something?
Yeah, well, right. I mean, so this would be, you just give, let's imagine that the thing that you gave was this. That's the target pattern.
Yeah.
Yeah, well, that's an interesting idea. I'm not sure how much ambiguity there is in what flows where. In other words, if it is the case that you say, I have a bunch of things and their flattened form is always going to have all elements in the same order. And now I'm simply going to sort of cluster the elements in
I think in a lot of cases, this would be something like find instance where there isn't like a unique solution to this. And we would just kind of have heuristics to figure out a sensible thing to do. Like if you didn't have underscore 3 times, for example, in that first list, and you just had, you know, blank sequence or whatever.
Yeah.
Maybe we could just automatically try to make a squarish shaped
Yes.
matrix.
Yes. Yeah, but basically what you're saying is, I'm going to make a picture of what I want. Now try and put it in that form.
Yeah.
I think it's interesting. And I think that that has a much higher chance of success than to give another 18 functions that, you know, I mean, I'm not sure how complete and whether it's necessary to even make it that complete, because as you say, I mean, in this particular case here, what we'd be saying is the pattern we want is blank arrow, blank arrow, association, blank. I mean, maybe we don't even need to, you know, whatever, blank, triple blank or something, pretty much. And then it's this thing here, dot, 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 or dot, dot. I think this is an interesting idea.
Yeah.
I mean, one could imagine generalizing this also to strings and things. Well, go ahead. What are you gonna say?
Yeah, I mean it's a very fuzzy concept, and you know, I don't think we could get things exactly right all the time, but maybe we could make something that's useful enough most of the time.
I think this is the direction to go. And we should talk about this in connection also with this whole string diagram type stuff, I think. Because that there may be an actual type formalism. Okay, there are three related things. Type specifications, this idea of 4 related things. Okay, so what do we got? We've got type specifications. We've got LLM examples. And we've got well, these pattern pattern-based structures, and then we've got sort of the string diagrammy type stuff, graphical representations. Does that make sense?
Yeah,
Yeah.
makes sense to me.
So our goal will be to bring those together with including, yeah, no, that's good. All right, let's quickly look at some of these others. Oh my gosh. Yeah, it's sort of interesting.
Is this also related to, I forget what we were going to call it, COMAP?
Yeah, it's somewhat similar to COMAP, where you're basically applying a list of functions to an expression. In this case, we're getting the keys are maintaining the head that was given, or the decoration as the rule form goes.
But we didn't actually get what happened to COMAP.
It's in the queue. It's in Danny's queue. It just wasn't.
It's
we
on
agree
my
we're
list
actually
for
gonna
the
call it
next
COMAP?
round.
With a
It's
lowercase m.
I'm a little bit suspicious about that name. I think it's one of
We've
these
gone
things.
round and round on it a few times.
All right, okay, let's not do it here.
Yeah.
Well, so if we talk about that again, let's talk about association through at the same time.
Okay. The last two are probably going to be slightly more complicated discussions, but select positions we started talking about, and Jose brought up this relationship that position is to cases as count is to cases, and we were
oh,
proposing.
I said it.
Oh, Danny. Okay, I'm sorry.
I don't know why I'm grabbing credit, but well,
I'm misattributing credit, but the idea was that having a test-based version of positions is potentially nice, but if we're going to go into a test-based version of that, do we want a select count also? Do we want a bunch of select related functions? I tried to do kind of a deeper dive on the pattern-based functions, and for the cases that we're looking at, I think select, position, and count are the primary ones. We're not really going to have a select replace where we're using a test-based replacement, because replacements inherently are going to.
Yeah, I mean, look, we've had the
pattern-based.
whole count by family, right? And this is now a thing a little bit like count by story.
It counts by, right?
Yeah, I understand.
Yeah.
But this is another thing a little bit like by. It's another adverb type thing.
Right.
And I feel like if we could come up with the right adverb, I mean, it's almost like positions by or position by, count by. Is it? I mean,
I guess the by functions would have a test function, right?
right. It's a little weird. By isn't quite the right, but is there another adverb that we can use there? It's not an adverb. I mean, another preposition we can use there.
Well, that would also handle like giving select a level specification. We wouldn't actually need that because you could have cases by or whatever we would call it. That would essentially do that, right?
Yes. Let's think about what that preposition could be. Okay, I want to make one general point and then we should wrap. As you all know, I've been working hard wrapping up this LLM function, all these LLM related functions for 13.3. I do think that now that the aliens have landed type thing, we're, there's just an awful lot of LLM related functions. And I kind of think that we should pivot a little bit in terms of these ILD discussions to look at, LLM spin-off functions, because I think that they are, they have high potential in the short term. And I guess we can talk about this, these things that I'm writing about these things and what's going into 13.3 is happening fairly rapidly. Probably by next week even, we'll have some more information about this. But I kind of feel like there's a, the LLM function is happening. We know how that's happening. And I think there's another idea of an LLM block function, which we should be talking about. So I hate to blow things up, but it's what we get when the aliens have landed.
We would need an LLM blockchain, of course.
It also might be worth looking through all the functions we have and see which ones would be useful as utilities in that ecosystem, things that have to do with templating and whatnot.
Templating or NLP stuff.
Right, because there might be some of those in the ILD list already that would be helpful.
And seriously, it might be a good idea to consider at least temporarily merging this with another group, since you have people working on this that are not in this group.
Sorry. I spaced for a second. Excuse me. Looking at something else. Could you say it again, please?
It would make sense to temporarily merge ILD with whatever group you already have.
Yes.
Not everyone is in this group.
No, I know.
Some are.
But a lot of the thinking that you guys are doing here is going to apply, to these other kinds of functions, except that I think that they have more bang for the buck right now. Because
No argument, but some of the expertise at the implementation level lies outside this group, and
I agree. But I mean, one of the things that's happening is because of LLM function and the related functions, a lot of the structure that has to be built now does not depend on detailed LLM knowledge. That's yes, I agree with you in terms of these meetings, but I'm also saying that I think the good news is that, sort of the generic ILD function building operation can be applied now to build out a bunch more LLM functions.
All the more reason to merge expertise.
Yeah, no, it is. All right, sounds good. Okay, I think we should wrap up here and talk to you soon.